is the Kirchhoff's law of electrical network. We have come across number of electrical networks in our daily life. At the usage at home appliances, in commercial, and also in electronic gadgets, maybe mobiles, laptops and other electronic items, where we come across the electrical network may be simple, complicated or even more complex in certain electronic devices. These electrical network, we get it by joining number of elements in series or in parallel. The elements in the electrical network are the electrical resistors. So these are the resistors like this. And the batteries or cells, and also the capacitors and inductors. We connect them in large number or small numbers to get an electrical network. What is important? It is to know what amount of electric current is flowing through each element in the circuit or in the network. And also what amount of potential develops across each element. To understand this, you have to go for the mathematical evaluation. For a proper mathematical evaluation, Kirchhoff has proposed the laws. They are known as Kirchhoff's law. There are two laws, current law and voltage law. The current law is called as Kirchhoff's current law. The voltage law is called as Kirchhoff's voltage law. What is current law? Current law means in the electrical networks, we come across number of junctions or nodes. What is junction? Junction is a point at which number of conductors are joined, and at the junction, through some conductors current is entering to junction, through some other conductors current is leaving the junction. According to Kirchhoff's law, whatever the amount of current entering the junction, this is a junction like this, same as total amount of current leaving. The total amount of current entering the junction exactly equals to total amount of current leaving the junction. Let us have the illustration with these two diagrams. This is the junction containing what is connected by three conductors. Three conductors. Through one conductor, the current is entering, the amount of current is I. Through other two conductors current is leaving. The current leaving is I2 and I3. That is, total current leaving is I2 plus I3. Total current entering is I through only one conductor. That is always equals. Current entering is equal to current leaving. That is Kirchhoff's law. If we take the network like this, junction containing 5 conductors, through 2 conductors current is entering, through 3 conductors current is leaving. So as per the law, I1 plus I2 that is a total current entering the junction. R0 says entering equals total current leaving, this plus this plus this. That is what the current law says. This mathematical equation can be rewritten as like this. Taking all this onto the left hand side, this is minus equals 0. They are also same thing. Taking all these terms on the left hand side, minus equals 0. What does it say? This is same as this. If you do so, the current, the symbol takes the sign convention, plus and minus. Plus for entry, minus for leaving. Here these are leaving, these are plus. Total, the summation is 0. Sum of all the currents equals 0 at the junction. But you see that which is plus, which is minus. Plus for entry, minus for leaving. That is what the law in brief. So summation is summation I is equal to 0. Sum of all the currents at the junction is equal to 0. That is the equation holds good. This is same thing is here. This is same. Sum of all the currents at the junction is 0. Here sign convention plus for the entry, minus for the leaving. 0. That is a statement in brief. Mathematical, that is a simplified mathematical statement of current law at the node. Summation I equals 0 is the law. What is second law? Voltage law. This is applicable for a loop like this, closed loop or closed circuit like this. So we have circuits like this. In this closed circuit or loop, we have number of elements. These elements are connected either in series or parallels. In this loop, we see that we have elements connected just as remaining of the elements. What elements are connected? This element is the battery, the cell. This element is one resistor, another resistor. This represents resistance of the resistor R1, R2, R3. And here the voltage source of the cell. Current flow is always like this. This is so that direction of the current or loop current. This is a loop current direction clockwise. Now what is the law says actually? Here there are number of that is elements are there. In some elements voltage rise, in some elements voltage drop. What element voltage rise? Cells like this, batteries, voltage rise, and the element like this resistor, voltage drop. Voltage drop means consume. Here voltage. So potential energy here rises, potential energy decreases, loss. In terms of potential, we say that voltage, that is potential rise and voltage rise, voltage drop. The same concept we can think or say in terms of energy. Energy means this current is carrying by the charges, electric charges. The electric charges are electrons. Here in these solid conductors, electric charges are electrons. Electrons actually take the energy from this cell. Energy what is generated from the chemical reaction in the cell. That energy is taking from here and that energy will come and give here. Take and give. Energy gain, energy loss. Energy gain, energy loss. Energy gain, energy loss. Like this is the circuit. What is the concept says? Whatever the total amount of energy gained, same as total amount of energy lost. That is, voltage rise is equal to voltage drop. Here only voltage rise at this element, voltage drop at these devices. So this is voltage rise, that is voltage drop. Voltage drop, voltage drop, voltage drop. The voltage across this voltage drop is V is equal to IR. V is potential difference or voltage. So V is equal to IR means for this resistance, what is V? I R1 I R1. What is the current? Current is same all over here. I R1. Voltage drop is current into resistance. I R1. Here I R2. I R3. Total drop, total rise is this. So rewrite this equation as like this. Taking all on the left hand side, minus equals 0. In this equation, here this voltage change will take sign convention. This is voltage changes, that is potential difference. Take positive, this is negative, this is negative, this is negative. So this voltage, that is sign convention positive and negative, it depends on the voltage rise, voltage drop, as well as the direction of the current. This is the direction of the current, that is called loop current. Direction of the loop current, the loop, that is clockwise. So this direction is same as this direction of the current in the loop. So accordingly we have, what is that? For this we have to understand what is the sign convention you are applying for this. This is one we are applying. Sign convention is this. This is cell. Cell means positive, negative. That is positive, negative. That is positive potential, negative potential. If the electric current flow in this direction from negative to positive through the cell, the voltage or the EMF or potential difference is positive. Potential difference, potential change will take positive. For the same cell, if the current flows in the opposite direction like this, positive to negative, the sign will take minus. We take minus, we take positive. For this, because it depends on the direction of the current. That is for this cell. What is for the resistor? A resistor like this is connected to a cell like this. A positive potential, negative potential like this. Positive potential, this is negative potential. So this is positive, this is negative resistor. If the current flows in this direction from positive to negative, the potential drop is negative. If the current flows in the opposite direction, like this minus to positive in the circuit, that is loop current direction, the voltage drops take positive. Remember this sign convention. This sign convention is important. Summation is that voltage difference, voltage difference, voltage difference, voltage difference. Summation, what is sign convention, very important. This will take positive, positive. This is same as this is. So this take positive, this will take negative, this will take negative, this negative, because in accordance to direction of the current, direction positive, negative, positive, negative. With this, keeping this technique in your mind, let us write voltage law for different what is that loops. This is one loop, other loop, another is. Because difference in the loops, we have increased number of the elements. In this loop, we have two cells. We have two resistors, and the connections like this: positive, negative, positive, negative, and the current flowing to always now from here in this direction. This is the direction of the current usually in the circuit like this. That is the positive. This is the direction of the current flow in this from this battery. This is the direction of the current in this battery. So these batteries connected that the current flows in the same direction. So through this. Then look at this, applying sign convention, voltage law. So this same thing what I written here. So here apply sign convention for this voltage law for this loop from this point to this point, and this point back again. Summate, what is that? Sum of all the potential differences. This potential difference is V1, takes positive because direction is this. This potential difference is V2, positive. This V2 is mentioned, potential of this cell, because direction is positive. And this potential drop is, this current is I, this current is I, total current is I in this case. IR1 minus means that is positive minus, takes minus. This also, this is positive, this is minus. It takes minus. So it is previously written like this. It is same as potential rise, potential drop. Rewritten like this, It is same as potential change, potential change, potential change, potential change, potential rise, potential drop, potential drop. That is same as this. Summation is 0. Summation is very important. That is the voltage law for this. What is voltage law of Kirchhoff? Summation delta V equals 0. What is summation delta V equals 0? Delta V means, summation means there are so many delta V. Delta V means 1, 2 like this. 1, 2, 3, 4. Depends on number of elements present in the loop. And take the sign convention, positive or minus. Depends on the direction of the current and the sign convention. That is why we have this. So, Kirchhoff's second law says that summation delta V equals 0 in a closed loop or circuit. That is, in a closed loop, what happens is the potential change, sum of all the potential changes equals 0. In terms of potential rise, potential drop. That is either in terms of potential or in terms of energy. I told you that energy is electrons are taking energy or energy here gain, energy loss. Energy gain, energy loss. It depends on the law of conservation of energy. This is based on the law of conservation of energy. In a loop, it is an isolated system. Isolated system, whatever the amount of energy, electric energy gained, same as electric energy lost. Lost by resistors, gained by cells. That is what the second law is stated. Next, let us apply the second law to other loops like this. The same kind of loop here, two cells are connected in the same fashion and resistors numbers are increased. Write the voltage law. This is the voltage law. Voltage law is, look at this, V1, V2. Current direction is important. Look at this, current is always from here to here. Current always from here, current direction. Current flow from positive in this direction, positive in this direction circuit. So in this circuit, this direction the current. So both the directions are same. Therefore, overall direction is this clockwise direction. It is called loop current direction. Same. And these are resistance. Write the potential differences. That is V1. Direction is plus. Direction is this plus. Plus plus. This is minus. This is minus. This is minus. This is minus. Direction, 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 direction. Minus, minus, minus. These are in terms of potential differences. Potential drop, potential drop, potential drop, potential rise, potential rise. Plus, plus, plus. Total equals 0. So this is the law for this loop. Now, what is the law for this loop? This loop is the same circuit, but difference here it is reversed. Minus, it is battery is reversed. Cell is reversed. The cell is reversed. Here, different element will take different current. In this battery, the current flow like this. In this battery, current flow like this in opposite direction, not in the same direction. Therefore, current through this resistance is I1, current through this resistance is I2, current through this resistance is I3, I4. This current direction in this cell like this. And that is the direction of the loop current. So, suppose direction of the clock is this clockwise direction, because it depends on what is the voltage difference. If this voltage is more than if this potential is more than this potential, current goes in this direction through this. Accordingly, looking at this direction, right, the potential changes. For the batteries, look at this, current direction is this, positive. For this battery, current direction, of course this will give the current like this, but the current, overall current direction is this, opposite direction. Current is going in this direction, this clockwise side. Minus. For this resistance, minus. For this one, minus. But for this one, look at that, this current is going in this direction, it is in the opposite direction of this. Minus becomes plus. For this resistance, resistor, it is plus. Similarly, for this resistance, it is opposite to the direction of the current, loop current. So minus becomes plus. So remember, it is a direction. If the current is in opposite direction to the loop current, plus becomes minus, minus becomes plus. So this is minus, minus. So instead of minus becomes is plus, plus. So that is 0. That is voltage law. Voltage law for this loop or closed circuit. Next is the circuit like this. The difference here, in these closed loops you have in series they are connected. Here the resistors are connected in parallel. These are connected in parallel. If they are connected in parallel, what is the potential difference? This potential is applied, same potential. Recall that resistors in parallel fashion, same potential at this, at this, at this. This is the potential. But the currents are different. If this is the total current, this current is dividing into, there is different branches, dividing into I1, I2, I3, and again combined to give that the same total current. The resistances are R1, R2, R3, current is I1, I2, I3, and there is a voltage battery. And in this diagram, see that it is not one loop. In this network, we have number of loops. That is loop like this, and loop like this, and loop, circular loop like this. Number of loops are possible. For every loop, the law is applicable. Let us apply the law for every loop. Some of the loops like this. Let me apply the law for the loop like this. Entire loop A, D, E, H, that is. And look at that, in this loop or closed circuit, what elements are present? There are only two elements. Look at this. These are not included. This element and this element. That is cell and resistor. And the direction of the current, look at that, direction is this. So the second law is potential is this plus. Potential drop for this is, the direction is minus. So this minus this is equal to 0. So this equation is applicable for this loop. Voltage second law. Similarly for the loop A, C, F, H, E. For this loop, what is the equation? Similar to this, there is no difference. There are two elements, element is cell and resistors. Current direction, that is this plus will take, current direction here, that is positive to minus, minus. So sum is equal to 0. There is the equation applicable for this loop. Similarly, let us apply, if you consider this as a loop, this loop has no cell, only resistors. C, D, E, F, C. C, D, E, F, C. Back to this point. The equation is, look at this, current direction. If you say this is direction, if you take as a loop current like this, clockwise, this direction, the current like this, but here current in the opposite direction. There are two resistors, there are two current flowing. One is in one direction, other in opposite direction. In this loop, if that is the case, if one takes positive, other takes minus. That is, it is almost a direction of the current. So one is takes positive, other takes negative. Voltage drop, voltage drop. Summation is 0. Similarly, we have this loop. This is a loop I am taking. Again, this loop contains only resistors. Similar to this. So that is two currents, one direction, it is in the opposite direction. In this loop, direction, but is in the opposite. Therefore, one takes plus, other takes minus. C D, this one C D E F C, this one. Here B C F G B, this one. One takes plus, other takes minus, equals 0. So these are the equations. I see that these are the equations in accordance with the second law for the loops are mentioned. For this loop, for this loop, for this loop, and this circular current, this loop. Equation, because these equations are very important. The summation, while doing so, summation, which one take positive, which one take minus, very important while solving problems, otherwise you go wrong. These are the one. And finally, I will take a little more complicated circuit. In this circuit, we have what is that loop, like there are two loops are there, and two loops are combined like this. We have the elements resistors. There are many resistors are there. 1, 2, 3, 4, 5, and two cells are there. And interestingly here that resistance of each resistors are mentioned, and voltage of both the cells are mentioned. It is 45 volt, it is 80 volt, and the current in each branch is mentioned in general. And through this conductor I3, but through this conductor I1, but through this one is I2. Here I2, different current. Here different currents, different ohms and different cells are there. You have to calculate. So you have to apply the second law. What is the possible equation for the different loops? You can take any loop. This is one loop you can take, and other loop you can take like this, and one more loop like this, circular. Now I am taking the loop like this: A, B, C, F, A. This is the loop I am taking. For this loop, write the equation, that is sum of all the potential changes and sign convention. For this one, current is like this: cell. Current direction, current direction is this. 45 plus, takes plus 45. For these two resistors, there is resistance is 1 ohm, resistance is 40 ohm. So they are in series, you can combine them. Total is 41 resistance. And current flowing through is I3. 41 into I3 voltage drop. What is the sign? Minus, because it is the direction of the current. This is positive, this is minus. Next one is, last one is this. This is the current is this. Resistance is 30. 30 into I1 is the voltage drop. 30 resistance into current. 30 into 5. And the sign convention, that is sign is, it is same as plus and minus. Minus it takes. Equals 0. So this equation holds good for this loop. Similarly, you can calculate what is the equation for this loop. Now I am calculating what is the equation for this loop. Look at the big, this entire loop like this. A, B, C, D, E, F, A. That is loop. In this loop, elements are this. This is element, this element, and this element. And the current direction, because in this case, is that this cell is involved. The current direction is this. That is the loop current. So for this direction of the loop current, suppose direction of the current is this, clockwise for this one. Right, what is the voltage? That is current direction is minus to plus 80 plus 80 mentioned. For these two, it is what is the total voltage drop. Here they are in series. 20 plus 1, 21 can take, and current is I2, 21 I2, and the sign is minus because this is plus, this is minus. Next, when you continue in this direction, this is the direction of what is the loop current, but look here, their current direction is reverse. This is the direction of current in this circuit. If the reverse, so instead of taking minus here, take plus. That is current voltage drop is 30 into I1. This is the current. 30 into I1 plus because of this current is in the opposite direction to the loop current. So this equation holds good for this loop. So why are these things? If you know these equations, you can calculate different currents I1, I2 like this. These are very important in solving problems. So like this, the Kirchhoff's law, the statement, and now we can apply the law to different networks. And what is the importance? You come to know in details when we are working out the problems. Thank you.